Hi, Assalamualaikum warahmatullahi wabarakatuh. Chapter 6, Acid, Base and Salt, Part 3, pH Value. Narrated by Teacher Nasreen. pH value. The pH scale is a scale of numbers ranging from 0 to 14 used to measure the acidity or alkalinity of an aqueous solution. Solution with pH value less than 7 is acidic, while solution with pH value more than 7 is alkaline. It is well known in a lower form, okay, about the pH value and so on. Okay, this is pH scale where 0 until 6 is 0 until 6 is acidic, 7 is neutral, and 8 until 14 is alkaline. So in upper form, 7.1 is here. 7.1 we call it as alkaline. Okay, 6.9 is acidic. 7.000 it's neutral. So decimal place, maybe about 2 decimal place will be considered in upper form. Okay, what is pH? pH is a logarithmic measure of the concentration of H plus ion in aqueous solution. This is the formula that you have to memorize. pH is equal to negative log concentration of H plus ion. Okay, the bracket here give you the meaning of concentration. Okay, concentration of the things inside the bracket, which is the H plus ion. Okay, next one, where log is logarithm of base 10 and H plus, actually we have the bracket here, is the concentration of the H plus ion, which is hydrogen ion, in mole per dm cube. Okay, mole per dm cube is the concentration of the solution and also the concentration of H plus ion in the solution. Now we go to example 1. Okay, I need you to be ready with your calculator. Calculate the pH value of nitric acid with a 0.5 mole per dm cube of hydrogen ion. So given to you is 0.5 mole per dm cube. What is 0.5 mole per dm cube? Yes, it is the concentration of nitric acid. Thus, it is also the concentration of H plus ion. So what should we do? Using pH equal to negative log concentration of H plus ion, write down. Okay, first on your answer, you have to write down like this. pH is equal to negative log concentration of OH minus. Oh, sorry, OH is 0.5. So how to calculate log 0.5? Using your calculator, okay, for me, my calculator is SBPM, what is FX 50570MS, the old one. I just switch on the calculator, type log. The log button is at the right side at top in the third line. Okay, log, and then type 0.5 and equal to. It will produce answer minus 0.3001. Okay, and you put like this. Okay, the negative here is from negative log. Okay, so when negative times negative, it will become positive, and your pH will be 0.301. It is a very strong acid. Okay, pH value of nitric acid is 0.3. Okay, so your answer, just leave it as 1 or maybe 2 decimal place. Now we go to example 2. Determine the molarity of hydrochloric acid with a pH value of 2.0. It is a reverse calculation. Given to you is the pH value, and you have to calculate the molarity. Using the same formula, you have to shuffle the formula and make the pH value, sorry, the molarity as the title of the calculation. Okay, the solution. pH is equal to negative log H plus ion. So put 2 here because we know the pH value is 2.0. Negative log concentration of H plus. And then you can see here, there are no negative in front of log because we have to transfer the negative into 2. Okay, all right, the negative 2.0 here, and H plus is equal to 10 power of minus 2. Okay, so when you using your calculator, 10 power of minus 2 actually is 0.01. How to put 10 minus 2 on your calculator? Okay, using my calculator, left side on the top button is shift. You just press shift and button lock, and it will give you 10 power of x, and then you put negative 2, and then equal to, you will get 0.01. If you need more explanation how to push the button on the calculator, okay, just mention and I'll consult you in the Telegram maybe. Thus the molarity of hydrochloric acid is 0.1 mole per dm cube. You need to put the unit, okay, or else your answer will be wrong. Okay. Now, exercise 1. So for those that have printed the previous handout, the exercise doesn't appear on your handout. So I need you to write down the questions and answer it. For those, just print out the latest handout. The exercise is on your handout. So do it first. Pause the clips. Okay, if you have finished, so this is your answer. Determine the molarity of hydrochloric acid. It contains 0.01 mole per dm cube. So this is the concentration of H plus ion. And again, you use the pH is equal to negative log concentration of H plus ion. This is the solution. Okay. So pH is equal to negative log 0.001. So log 0.001 is actually minus 3. And minus 3 times, sorry, minus times minus, you will get positive. It will become 3. So the pH value for HCl is 3. Okay, just write down your final answer in a sentence like my examples. Okay, pH value of nitric acid is equal to 3. The concentration of hydroxide ion is used to calculate the value of pOH. Okay, previously we have learned about acid. Now it is about hydroxide, which is alkali. Okay, in alkali, the OH minus is very important to determine the pH of the alkali. So OH minus is used to calculate the value of pOH of an alkaline in aqueous solution. So the formula of pOH is equal to negative log concentration of OH minus ion, where log is logarithm of base 10, while OH minus is the concentration of OH minus ion in mole per dm cube of the solution. Actually, OH minus, we have a bracket to show it is the concentration of OH minus. The concentration of hydroxide ions is used to calculate the value of pOH of an alkali in aqueous solution. So pH plus pOH is equal to 14. So if you would like to calculate the pH of an alkali, you have to minus 14 with the value of the pOH of those alkali aqueous solution. Okay, now we go to examples. Make you more understand how to calculate the pH. Oh, for this question, the question asks you to calculate the pOH value. Okay, just the pOH value. So given to you is the 0.1 mole per dm cube. Oh, so what is the value of what was that? 0.1 mole per dm cube is the concentration of sodium hydroxide. It's also the concentration of hydroxide ion inside sodium hydroxide. Okay, using the formula of pOH. Okay, pOH is equal to negative log of the concentration of sodium hydroxide. Okay, just put the value of 0.1 here. Okay, and calculate again. So log of 0.1 is negative 1. And again, negative times negative, it will become positive, and your pOH is 1. POH is not pH, okay? POH is the POH, okay, value of sodium hydroxide. If you would like to calculate the pH of the sodium hydroxide, you have to minus pH, I'm sorry, 14 minus 1, the value of POH, then you will get the pH value. Maybe the next example, okay? Now we go to example 4. Yes. This example, this questions ask you to calculate the pH value for potassium hydroxide solution. And given to you is 0.01 mole per dm cube, which is the concentration of potassium hydroxide. So I can see here there are two-step calculation in these questions. First, you have to calculate the POH, and when you will get then after you get the POH value, you minus POH value from 14, then you will get the pH value. Okay, let us see how to calculate these questions. Okay, solution, when that the concentration of hydroxide ion is 0.01 mole per dm cube. So POH is equal to negative log concentration of OH minus ion EU, which is 0.1. So log 0.1 is minus 2. Okay, so minus time minus is 2. So POH value is 2. It's not your final answer because question asks you how to calculate the pH. So pH is equal to 14 minus POH, which is 14 minus 2. So your final answer will be 12. Okay, get it? Next one, example 5. Determine the molarity of lithium hydroxide solution with the pH value of 12. Given to you the pH value, so it's a reverse calculation where you should calculate the POH first. Okay, you have to find out the POH first. That is the first step calculation, and the second step, from the value of POH you calculate the molarity of lithium hydroxide. Okay, let us calculate together. Solution, pH plus POH is equal to 14. So to get POH, rumbles the equation, and you will get 14 minus 12, and your POH is 2. So take those POH value in the what? Yes, POH is equal to negative log concentration of OH minus, and you put 2 for the value of POH. Okay, and again rumbles and shuffles everything. No lah, just put the negative here in front of 2. Okay, because we would like to have only concentration of OH minus. So the logs is transferred into the right side. It will become 10 power of minus 2. Where did I get minus 2? It is from here, right? From the previous calculation. And the concentration of OH minus is 0.01 mole per dm cube. Okay. Molarity of lithium hydroxide solution is 0.1 mole per dm cube. Molarity, okay, molarity and concentration is the same thing, okay? Molarity, concentration. Sometimes some people say it's molarity, and some questions ask you about concentration, but the unit is same, which is mole per dm cube. Okay, now it's time for your exercise. This is the second exercise. We have only 2 exercises in this clip. Okay, read the question first. Determine the molarity of pH value for calcium hydroxide with the formula CaOH2 with the concentration 0.05 mole per dm cube. So that is the concentration of OH minus, because calcium hydroxide is alkali. So alkali consists of OH minus ion. And given to you, pH plus POH is equal to 14. Okay, I need you to pause the clip and try yourself first. Okay, nice try. Okay, this is the solution. Okay, firstly, you have to calculate the POH for calcium hydroxide. POH is equal to negative log 0.05. So calculate log 0.05 is minus 1.301. So minus time minus, you will get positive. So your answer will be 1.301. Just leave it as one decimal place, it's okay. So your pOH is 1.3. Okay, the question asks you about pH, not pOH. This is just your first step, getting the pOH with a value of 1.3. So next one, pH value is equal to 14 times of, it's not times, minus pOH. So 14 minus 1.3 is equal to 12.7. So the pH value for calcium hydroxide is 12.7. Okay, very good. Next one, yeah. The pH value and the concentration of acids and alkalis. The higher the concentration of H plus ion, the lower the pH value. Acidity increases when the pH value of the acid solution decreases. Opening. Okay. Concentration of H plus ion higher. Okay, I like here. The pH value lower. Okay, remember this is for acid. The lower the pH value, okay, I give you the scale. The lower the pH value, the stronger the acid it is. So the higher the concentration of H plus, the lower the pH value, the stronger the acid it is. You have to memorize and remember that. Okay, this is higher, the lower the pH value. But the lower the pH value, the stronger the acidity it is. Okay, this is for acid. Okay, next one. This one is for alkali. Okay, the alkali is OH minus. Yeah, there are OH minus ions inside alkali. Okay, the concentration. Okay, I read it first. The higher the concentration of hydroxide ion, okay, comma here, the higher the pH value. Alkalinity increases when the pH value of the alkaline solution increases. Okay, using our scale again. Let us see here. The stronger the alkaline it is, it has a higher pH value. So the higher the concentration of OH minus, OH minus, the higher the pH value. Okay? So directly proportional. But in chemistry, we cannot use direct proportional. It's just higher, okay? So the higher the concentration of OH minus ion, the higher the pH value, the stronger the alkali it is, or the alkalinity is higher. Alkalinity. Okay? Okay, end of part 3. Thank you.